Hi, and welcome to Tree School Online. I'm Julie Woodward with the Oregon Forest Resources Institute. It's my pleasure to be your host for today's Tree School Online webinar. Tree School Online is a production of the OSU Forestry and Natural Resources Extension Program and the Partnership for Forestry Education. We want to give recognition to the Oregon Forest Resources Institute for contributing to this project and to the Forest Service and the Oregon Department of Forestry. Thank you for joining us this month to discuss woodland roads. Are you ready for winter? Many of you have probably joined Tree School Online before, which we appreciate you coming back. If this happens to be your first time, let's make sure you know a few things about the Zoom webinar. The toolbar should be located at the top or bottom of your screen. Oftentimes, if you roll over that, you can get things like if you want to ask a question, you'll need to go in the Q&A box and just type that in there. We'll monitor that throughout the webinar and have a few times throughout that we'll answer those questions in the middle and then also at the end. We also, you don't have audio and video right now. That's turned off for all participants. But again, you can ask questions through there. If you have technical issues or just a general question, you can do that in the chat. And Glenn Ahrens with OSU is helping to monitor the chat. So feel free if you have something you'd like to put in there that isn't a question, we can get to that. There are resources that'll be mentioned throughout. Those are going to be in the Tree School Online class guide page, which you can reach from the Tree School Online page on Know Your Forest or through the OSU website. We also will be recording this session, so you can go back and look at it, or if you want to share it with others, it will be archived on the YouTube video and accessible on the Tree School Online pages. We'll also be asking some polls throughout. They should just pop right up. If not, you can push on poll and you can use that during the webinar and you should be able to answer those couple questions we'll have at the beginning and the end. So today we're very excited to welcome to Tree School Online, Francisca, Belart, and John Souder. And let me tell you a little bit about Fran and John. And their presentation today is on woodland roads. Are you ready for winter? And Francisca Belart is the assistant professor and timber harvesting specialist in the College of Forestry, the Department of Forest Engineering, Resources and Management at OSU. Before starting her doctoral studies, she worked as a planning engineer for a large forest company in Chile. As an extension specialist, she teaches harvesting systems, timber sale management, and forest rows to small woodland owners around Oregon. Her research interests are related to logging safety and cable logging systems and new tethered mechanized systems, as well as forest planning, forest economics, and forest residues for energy production. And John Souder is the assistant professor and specialist in forest watershed extension with a joint appointment at Oregon State University in the Forest Engineering Resource and Management Department, as well as with the extension. Prior to coming to OSU in 2015, John was the executive director of the Coos Watershed Association in Coos Bay from 2000 to 2015. And before that, taught at Northern Arizona University and worked as a fish and wildlife biologist with the U.S. Fish and Wildlife Service. So I appreciate both of them taking the time today to join us. And Fran's going to give us a little overview about what they're going to share today.
Thank you, Julie. Hi, everyone. Thanks for joining us today for Woodland Roads. Are you ready for winter? So the first question that I always like to point out when we are talking about roads is why are roads important? Roads are very important, and we sometimes forget about them until they don't work. But woodland roads provide access for forest management, for development, for wood extraction, for protection, especially when we have these terrible fire seasons, right? We need access for conservation as well. Roads are also a huge capital investment for properties and land value. And one of the reasons why this is a big capital investment is because roads are quite expensive. And if we don't maintain them correctly, then there's a huge cost associated with it, with repair. So we need to be able to keep those roads functioning. They also have environmental implications, especially for water, and that's why we will highlight water, because winter equals tons of water. So they have those implications for habitat fragmentation as well, and fish habitat, within many others. And they also have legal requirements. The Forest Practices Act has several rules that talk about forest roads and how to manage those, so we diminish the environmental implications of having roads out there. So today we will touch on all of those topics, and that's kind of a summary of what we'll be talking today.
Thanks, Fran. Well, I appreciate that, and I look forward to hearing more about all those topics with you and John. First, we're going to launch an opening poll, and we're going to ask the audience, the attendees that are with us, just 3 questions. So if you can go ahead and click on those, whatever best fits your answer. So the question is, where are you from? So you have a couple options there, from around Oregon, or maybe Washington or US, or outside the US. And then if you can tell us about yourself, woodland owner or a private natural resource professional, agency, or other. And then about how much acres of forest land do you own or manage? And that just helps give us and our speakers a little information about who is out there. As always, we miss seeing all of you together in a classroom or on a field trip. But this is a great way for us to get some really valuable information here before winter really sets in and all of the rain. As we've already heard, there's atmospheric rivers and all sorts of rain events happening this winter already. So this is a really great time to be thinking about your winter roads, and we appreciate you participating in the opening poll. So we're going to go ahead and in that poll, if we'll just give one more second, any last people to come in and share that. And so have found it interesting over the last year where we've been doing the Tree School Online of where people are joining us from. And here are the results. And so you'll see that we have about 48% are here in the Willamette Valley. We have many on the coast. So John can relate to that coastal area. We have Southwest Oregon, we have some Washington and other parts of US. We have primarily 65% woodland owners. We have natural resource professionals from both agency and private, and then just others joining us, which we appreciate that wide spectrum of audience. And I can also see we are across the different spectrums of land and management from 0 to over 1,000. So thanks everybody for sharing where you are at today. It looks like someone's even saying greetings from Nevada. So appreciate people joining. So we look forward to getting more information. And with that, I'm handing it over to John to take it from here. Thanks, John.
Right. Thanks, Julie. And I appreciate the introduction. Let me see if I can actually get this to, there we go. So what I'd like to talk about in kind of a short preface to the workshop is why are we concerned about water quality, and where do the water quality problems come from? And then we'll get into, in a later part of the session, how to avoid a lot of those problems. So really, we've got water quality, and particularly the water that's coming off of roads, affects, like Fran said, it affects the physical habitat in these streams that are receiving that water. It affects the sources of food that organisms have in that water, the aquatic food webs, and then ultimately that also affects the fish. And the fish are the cause of a lot of the regulations that we have now for it. When we look at various sources of sediment in streams, we kind of have 2 general classes. One are the catastrophic things, and we'll talk a little bit about landslides and some of the other problems, particularly those that are related to roads, but also some of the chronic problems that we see that are caused by roads. And then finally, I want to go through a little bit about kind of how we look at a road in relationship to the water that's hitting the road and flowing off of the road for it. So I think the first thing to look at is to think about kind of, we talk generally about, you know, sediment in streams, but there's really 3 different types of material that enters streams that can have both positive and deleterious effects. So that's dissolved in the water itself, suspended in the flow of the water, and then the material that's on the bottom of the stream that can move around as well. So the dissolved stuff we generally call turbidity, and turbidity is essentially the lack of clarity in the water. So it's measured by how much light is not transferred across a column of water for it. And turbidity is caused by a number of factors in water. It can be very fine clays and silts in the water. It can be both inorganic minerals, and it can be organic matter as well, such as tannins that oftentimes are present depending on the type of forest that you have. And then it can be things that are actually produced in the stream, like very fine algae and plankton in there for it. And why we're concerned about turbidity is that fact that the major fact for it in terms of aquatic systems is that it restricts photosynthesis. So we have processes in streams where there are algae in streams that are photosynthesizing, similarly to the photosynthesis that we get from plants on above ground for it. So that happens in streams. If there's not good light penetration in there, then that level of photosynthesis is reduced quite a bit. Some of the other concerns that we have in terms of turbidity, and particularly these very fine particles that are dissolved in the water column, is that they are sites that attract things that we typically don't want in our water. And those are heavy metals, a lot of pesticides, even some bacteria get attached to these very fine particles, and then they get transported downstream. And we've just done, working with Julie and Ofri, we've just finished a 3-year project looking at the effects of forest management on drinking water quality for those water systems that use surface water, and turbidity is one of the significant problems there. And again, it's because of a lot of these things that get attached to it. So the other concerns that we have about turbidity is that most aquatic life has gills. I mean, fish have gills, but a lot of the other aquatic organisms in streams, also have gills. And these very fine particles tend to clog those gills up. And then that causes respiratory problems for fish, similarly to, I think think about what you feel like when you're in an area that has a fair amount of wildfire smoke, and you can have difficulty breathing, you get stressed with it, your kind of heart rate goes up and all of that. And the same thing or something similar at least happens with aquatic organisms as well in highly turbid water. And then finally, if you're out looking to find food, again, think about if you were trying to hunt in some of these areas that had quite a bit of wildfire smoke in them, you're going to have trouble finding your quarry. And the same thing happens with aquatic organisms who are site feeders, and that's a lot of the fish, small fish that we're interested in are site feeders. And so if they can't see the food, they're going to go hungry as well. So turbidity is probably in many ways, turbidity is probably the largest concern, and it is the attribute of this whole sediment complex that's regulated. So the Department of Environmental Quality sets standards for turbidity for it. And typically, if you can see it, you've exceeded it, is kind of a good rule of thumb for that. The next one is suspended sediment, and these are the particles that are essentially entrained in the flow of the water, and a lot of that occurs during the freshets that we're starting to get now for it. And so these are larger particles. They're typically kind of more sand-sized grains, and those are carried along with the water until the water slows down sufficiently that it doesn't have the power to hold that material in suspension anymore, and then it drops out. And so when that material drops out, it has the potential to smother spawning gravels. It just basically fills up the interstices between the gravel. That prevents the water from going through that gravel, and it's the water that's carrying the oxygen that fish need and the fish eggs need for it. And it doesn't also allow that water to get through and take out the metabolites that the eggs are producing as they're maturing for it. Again, talked a little bit about the stress factor for it. Think about if you're out on the coast on a very windy day, on a beach that has a lot of sand, and you've got that sand blowing at you for it, or if you're in a dust storm. I was just over in Eastern Oregon a couple of weeks ago, and there were some pretty substantial dust storms for it. So, again, think about how you feel if you're in that. You have trouble breathing, your heart rate's probably going up. You're trying to figure out how to get out of it for it. And so those are kind of some of the physiological responses that aquatic organisms will typically have at times when there are high suspended sediment levels. And then that sediment can also get into their gills with it and cause damage to the gills as well. Now, the third piece of this kind of sediment equation is what we call bed load. And that's the material that's on the bottom of the stream. Typically, we think about that as gravel. It can go all the way up to cobble size for it. And this material is actually beneficial, but again, it has some problems if it moves a lot during high flows with it. So the beneficial part of it is that these are the gravels that are used as spawning beds by most of the salmon and the trout that we have. And when those are in, fairly deep or reasonably deep levels of gravel, then you get a lot of water moving through that gravel. And as that water moves through that gravel in what we call the hyperrheic zone, it cools off. And cool water is typically good for cold water fishes, like salmon for it. Now, what happens also, though, is particularly during storm events, this material is moving down along the bed of the stream, and in some cases kind of bouncing along the bed of the stream or rolling along the bed of the stream. And so it can deteriorate, particularly if it is sandstone-based material, which we have a lot out on the coast. And so that gravel can very rapidly turn into sand. Sand's not necessarily a bad thing, but I guess if you had to have a hierarchy, gravel is probably better than sand for it. And the other thing that happens when that bed load moves around a lot is it can scour things. So it will scour the algae and the aquatic plants that are living on the beds and the banks of streams. It acts essentially as a sandpaper along the banks of the stream. So as this is moving down, it can actually erode the banks of the stream with it. So again, bed load and those gravels have both beneficial effects in the stream and can also have adverse impacts. So where does this stuff come from? So there's a number of sources for it. One of the most significant ones is what we call mass wasting. Other people call landslides for it. And this is typically on steeper, unstable slopes. Again, this Tyee sandstone region on the coast is fairly notorious for its landsliding for it. And so essentially what happens is when a chunk of this earth on the side of a hill loses or has so much weight that it loses its kind of attachment to the underlying bedrock that it's sitting on, it can slide down the hill. And so things that are causing it to stay in place, one of the major things that's causing this soil to stay in place are roots for it. And so one of the things that happens when you cut an area is that you end up losing that root strength with it as the stumps deteriorate and the roots deteriorate. And so that typically occurs 5 to 7 years after a harvest. And so you can get some instability beginning at that time, not immediately after harvest, but within 5 to 7 years after that. Clearly, as we've seen these last couple of years and have a longer history of it, forest fires are going to have that same effect. If they kill the trees, the roots are starting to decay. And then in addition, you've got a lot of standing weight on top of that soil as well that's no longer contributing to holding that soil for it. What we're mostly concerned about, and particularly today, is the effects of road on a potential increase in landslides. And that will happen when you build roads across the tops of steep head walls. And it can also happen when you've got side cast fills in the road or for landings that end up being saturated with soil. And when they get saturated, they get so heavy that they tend to slide as well. So that's a summary of the story of the mass wasting and effects on landslides. And those can put significant amounts of soil into a stream, as many of us have seen. Okay, so we talked a little bit about the sidecast roads, but road fills in general can be hazardous, are in fact hazardous locations for it. When you have roads crossing streams, typically you have some sort of culvert to convey that water from the upstream side of the road to the downstream side of the road. And then you may have fill material in that crossing to create a level road surface for it. And these fills can range from, a small amount, 5 or 6 feet. I think probably the tallest fill I've seen over a culvert has probably been about 80 feet of fill for it. And that's a significant, that in fact became a safety of dams issue for it. So what the problems are is that if a culvert gets blocked for some reason, or if it's undersized, so it can't pass the capacity of water that's coming down, then the water is going to go someplace. And then typically what's going to happen is that it's going to build up on the road fill or upstream from the road fill until it starts diverting over the surface of the road, and sometimes down the road if the road's on a hill, and that starts eroding the fills out for it. Improper culvert installations and old and kind of derelict culverts can also have problems. If the fill is insufficiently compacted, then the stream may find out that the easiest way to go is alongside the culvert rather than through the culvert. And as it goes alongside the culvert, it's eroding that material out, similar to the picture on the top there. And then finally, if culverts are so old that they've begun to rust, they're losing a lot of their structural integrity for it. And so they can collapse as well. And when they collapse, then that cuts their ability to convey water down, and then the water's still going to go someplace. So I think the key term here is the water's going to go someplace. And if it can't go through where you would like it to go, it's going to probably go through someplace that you're not going to like where it ends up. Okay, and then so those first two, the mass wastings and the fill failures are fairly catastrophic, or what we would call a catastrophic event, in that they are relatively infrequent, but when they occur, they can put a large amount of material into streams. But we have this other type of sediment inputs that are really chronic with it, and a lot of the chronic inputs are a result of road drainage and the road surface itself. When you're hauling and doing a lot of hauling on a road surface, you're breaking the aggregate down or the gravel down. And Fran's going to talk about that in a minute. And when that gravel breaks down, it's breaking down into these fine particles, which would be, typically the suspended sediment component that we talked about earlier for it. The other thing that's happening and the figure on the lower right describes this, is under heavy truck traffic, particularly when the road is saturated, you get what's called sediment pumping up from the subsurface of the road, which tends to be native material or soil, coming up through the rock and ending up on the surface of the road. And that's happening because you've got a lot of bouncing going on. You've got a kind of saturated road fill. You've got heavy trucks going down this, and particularly if they're braking, then you're going to get a lot of bounce on those tires on the truck. And as it's bouncing up and down, it's pulling this material up from the subsurface to the surface of the road. And that picture on the right is part of a study that I was involved with, where we were actually monitoring the road surface contributions for a ditch. And I was standing there watching this happen, standing in the rain, watching this happen as there was a lot of truck traffic through this area with it. And you could just tell that as it was raining and as there were traffic, you were getting a lot of this piping up from the subsurface of the road to the surface. And because it was raining, it was then running right off into a ditch. And as you can see in the background of that photo, that ditch was then going into a small tributary stream for it. So we know kind of how to fix that stuff, or how to reduce that problem. One, and again, Fran's going to talk about it, is the quality of the gravel that's used for it. But we'll talk about some other things, that road surface drainage, and how the material or the water and what's coming with the water, how that's draining off the road and where that's going is also really critical. And part of that is related to the distance between the road and the stream for it. And so what we're looking for in that distance really is there a sufficient buffer area so that material that's suspended in that water drops out before it gets to a live stream. Okay, so then what we call this relationship between the road surface, and the ditches and the streams is what we call hydrologic connectivity. Are these things connected with stream flows, for it? So we have sediment coming off of the cut banks in there. So it's sloughing off of the cut banks, particularly in wet weather for it, and going into ditches. We also have the sediment coming off of the road surface. And if the road is crowned, then you have essentially half of the road surface that is delivering into that adjacent ditch in there. And then the hydrologic connectivity is when that water and that material that's coming off of both the road surface and the cut banks ends up in a stream with that. And so that's the nature of the problem. If there was no input into the stream, that's still a problem, but that's a maintenance problem and not a water quality problem for it. So I think that's the kind of introduction to kind of where, the nature of the problem with it. And so Fran's going to talk now a little bit about kind of how road design, and some of the road maintenance parts of it can reduce those impacts. So I'll let Fran cover that now. Oh, but let me do the take-home message. Sorry, we should do this. So good that we both have control over this. So the first one is, we have the first one there. So first thing to remember, sediments can be harmful to aquatic life. We know the sources of these: landslides, fill failures, breakdown of gravel for it. And the most, and really the topic that we're covering today is kind of how do we reduce these problems by disconnecting roads from streams? Okay, thanks. And now, Fran.
Thanks, John. So we'll talk a little bit about some technical aspects, very general of roads, so we can better understand how water kind of goes through the roads and into the road drainage. So typically we have forest roads, and so they have the very basic idea is that we have the subgrade, which is the natural soil that has been compacted, and also we have forest roads that have rock or aggregate on top. So that adds an additional layer of rock that basically takes the vertical forces that are caused by the load and the horizontal forces that are caused by braking or the traffic onto this road. So one of the things that I always like to talk about is subgrade. Whether we have a dirt road, which is the subgrade in itself, or we have a layer of rock on top of it, the subgrade is, I would call it the foundation. If you think that you're building house, your foundation is very important, right? So in the road world, the subgrade is the foundation of the road. So if you have a weak subgrade with a weak soil, you will have a very expensive road, and it will be non-functional because you're always going to have to be repairing it. So weak soils, for example, wet clays, usually need to be treated in certain ways to increase their strength. And this can be done by either densifying the soil, which means compacting, right? It could be by drying it. It could be by using geosynthetics, and we'll talk a little bit about that when we have some wet spots. Or it can be used, it can be stabilized with additives, such as lime, cement, asphalt, or other options. The target of the compaction for the subgrade is, the ideal is to get to the 95% of the maximum compaction or dry unit weight that soil that can achieve. And that will, of course, depend on the moisture content. Usually for wet clays, the best additive is lime, and that is readily available, is fairly economic. But if you have, for example, coarse grain soils, other options such as cement or asphalt work much better. Another aspect of the road surface and the subgrade is what is called the road prism, which is the shape of the subgrade, because what we want to do, and this is the most important take-home message that we want in this webinar, is that you need to keep the water off the road. And the first way of doing that is by putting certain slope on the road surface so the water drains towards the side. And the basic three ways of doing this is what's called a crown road, an outsloped road, or an insloped road. For the most part, the crown shape is the most used around Oregon, which is shaped as a crown, and so it drains the water towards both sides, and then the water is collected on the ditches. Usually the grade that we want on these is between 4 to 6%. Usually less than 4% is not enough, because we really want to get that water off the surface of the road. The shape of the subgrade is very important in a way. When a new road is being built, the subgrade needs to be shaped in that same way. So if you have a crown road, the subgrade also needs to be crowned. Otherwise, there's a lot of aggregate that needs to be put on top of that subgrade to be able to achieve that level of grade on the crown of the road. And aggregate is pretty much the most expensive part of the road. So we want to try and do the subgrade and shape the subgrade before we put the aggregate on top. So here's a comparison between dirt and rock roads. What I call dirt roads are the ones that don't have any rock in it. The good thing about those is that you don't need to buy or haul the rock. However, they do have higher maintenance, right? The rock is pretty much what it's doing is draining that water. So it's keeping the surface dry. And for that reason, it makes it better in terms of lower maintenance. A dirt road might not be operational all year. It might not provide access year round. There's of course higher potential for sediment, and it might need more cross drain, dip, and bars to be able to get that water off the road, because we're not using the rock to drain that and dry out that surface. Now, rock roads or aggregate roads need to be, of course, the rock needs to be purchased, or if you have it in your property, you need to transport it and treat it in certain ways. So it has an additional cost, of course. However, over time, it's lower maintenance, and that is also kind of a saving side of things of having rock. It also provides all year access, especially for people who want to do harvesting during the winter time. It's very important. It provides way better weather drainage. And for that reason, you need less or fewer cross drains. And also it reduces the amount of dust that is produced during the summertime. So in terms of aggregate, not all aggregates are created equal. We have a lot of questions about, what kind of aggregate to use, and to summarize, we have sand and gravel, and we have crushed rock. Gravels are coming from river valley floors, and they're extracted from gravel pits, and they are treated or crushed, because what we want is to have edges in which these particles can touch and compact on the surface of the road. So if you have round rock, that is really hard to compact. And for the most part, no matter how much those are crushed, there's always round edges that are left. And for that reason, they are not the best option for a surface. Of course, for that reason, they cost less as well. And then we have crushed rock that is, basalt in higher elevation, which is obtained by drilling and blasting at the quarries, and then treated or crushed into smaller sizes, and then it can be utilized on the roads. So of course that is a little more expensive, but it's definitely the most effective type of aggregate for forest roads, because it compacts very well. So here is an example of how a typical forest road, and I think this is pretty much a standard for industry, of how a road looks like, a forest road that is being ready for winter. And that includes a very well compacted subgrade, and then a base course that is 6-inch minus rock, and that means that the rock has been through 6-inch holes, so it's about a 6-inch and less diameter size for that. And then on top of that, there's a 3-inch minus or 3-inch rock on top. Of course, each course has to be very well compacted, and the reason why a larger rock is used right after the subgrade is because it provides better drainage, right? So we have bigger rock, we have bigger gaps in which the water can drain. But if we wanted to have 6-inch rock on the very top of the surface course, that's a little too rough on the tires. In other cases, when there are very steep sections, a smaller size rock is used because that helps with the traction. In terms of price, of course, the smaller the rock is, the higher the cost or the price for the rock is. But if you look at this, this is price of dollars per ton, and most trucks carry between 12 and 15 tons of rock. So the cost of the rock is not as high. However, the trucking is usually the most expensive part. And this will, of course, depend on how far the rock pit is from your property. So the farther you are, the more you're going to have to spend in getting that rock into your property. Of course, very important that, you know, if you're going to rock your roads, and because you're thinking about hauling timber in the winter months, the best time to build these ones and to rock the roads is in the summer. And compaction. If it's not well compacted, then it's not good. And what that means as well is that the more we compact this rock, the more rock we need to put in. So of course that also influences how much the road costs. But if the road is well built, your maintenance costs are going to go down, and you will have a year-round functional road. For wet weather hauling, of course, we want the maximum feasible size aggregates and limit the amount of fines that are in that aggregate to avoid sedimentation. Why we want the bigger size aggregate possible? Because we want that water to drain out. In other cases, if the road is being roughed for low clearance vehicles, then you need a smaller 3/4 inch to 1 inch minus aggregate to provide better traction. And also because the larger the aggregate is, the more wear you get on the tires. So the large aggregate, maybe log trucks can handle it, but other vehicles cannot. And of course, if the grades are really steep, then you are going to want a smaller aggregate, or in a very steep and curved road, to be able to aid with the traction of those vehicles. So why fines? I mean, we think about this, we are trying to avoid generating sediment, right? So it doesn't really make sense to have any fines on the aggregate. However, if we have too clean of an aggregate, then the particles, when this road is being compacted, the particles can bind. There's nothing in between them. So we need a little bit of fines to be able to provide contact for those aggregate particles and be able to compact them well. However, if those particles are way too many, then the aggregate will be floating pretty much in this sea of fines. So there's always has to be a good balance in between those. And for that reason as well, we do have the larger rock in the bottom of the road and then a smaller rock on the top, because we don't really need that much binding on the bottom. We just actually want the water to flow down from the surface. This is a very common question that I get about roads. How much timber do I need to harvest to be able to make it pay for rocking the roads? And many small woodland owners want to take advantage of usually higher prices of timber in the wintertime, right? However, in the wintertime, you might not have access to those trees. So I made this little comparison here that pretty much tells the break-even point between how much timber or how much the total sale needs to be able to break even. And this is assuming that the harvesting cost is $350 an MBF, and that we want to put rock in 1 mile of the road, so which is quite a bit, right? At a $70,000 cost for putting rock and leave that road ready to go. So if we assume that the prices of Douglas fir at $750 an MBF, then you would need 175 MBF as a total sale volume to be able to break even and pay for that rocking of that road. And that is about 45 truckloads if we are thinking about 175 MBF. Now, that seems like a lot, right? However, if this road is leading to other harvest units, and you have potential for harvesting other units in the future, you need to take this as an investment, just like I was talking about, an investment and a road that will be functional all year round. So we talked a little bit about the surface and how important it is to keep that water off the surface and how to utilize the rock. Now that the water is off the surface, where does the water go? The first one is the typical side ditches, right? These ones collect the water that are falling on the road and reduce the water table in the vicinity of the ditch. So we want to get the water off the road and then direct it into these side ditches, so we can effectively drain that water out. Then we have culverts. Culverts, what they do is to carry the water across the road to drain the side ditch, because as the length of the road goes, a lot of water starts to accumulate. It's just coming off the road all the time. So we have an accumulation of water, and at some point we need to carry it across the road to drain this side ditch. And what we use for that a lot of the times is these culverts. Culverts need to be placed at an angle so they aid the water flow, so it just flows out of the ditch. They need to, we need to make sure that those are not draining into slopes that might erode, and then road failure might occur, especially if we're talking about sidecast roads and things like that. Otherwise, there are some things that can be done, such as using an armor ditch or half a culvert or something like that, that can help stop the energy of that water that's flowing out of the culvert. When culverts are impractical, or we cannot use those, we can use road-based dips or rolling grades. These work well for taking the surface runoff out of the outslope roads, the ones that are just sloped out. And they are lower cost in maintenance compared to culverts. However, this needs to be built in a way that are not going to affect any low clearance vehicles, such as lowboys, for example. When you have a harvesting operation, you might need to bring in a lowboy, and if these are not built correctly, then you might have access problems to the harvesting operation. Other ones are water bars. These are usually located at an angle to the road between 30 to 45 degrees. Sometimes they're not very user-friendly, especially the ones that are just built right onto the road. Of course, they're low cost. The spacing in between them is the same as for many of the other drainage outlets. And sometimes what you can do is that you can use old belts for water bars, and that's a very economical option, unless there's very heavy traffic, in which it might not work very well. So let's briefly talk about geosynthetics. So these, what they do is to provide separation, drainage, and reinforcement. These are ideal for wet spots. They're not really meant to be implemented across miles and miles of road. It's more ideal for spots. They reduce the need of aggregate, and they're effective for soils that are very weak, including clays. And then usually these are placed, and then 9 to 10 inches of aggregate or rock is usually put on top. So we have two types of geosynthetics. The one on the left is the geogrid that provides reinforcement and helps interlocking the rock that is being placed. And we also have geotextile, which also provides separation between the layers of the road. They provide strength and also help with water drainage. So if there's a spring or a spot on the road that is constantly wet, these definitely is a really good option to help with water drainage and keep it off the road surface. So now I will pass it on to Julie.
Thanks, Fran and John. A lot of great information. I think we had a question from Chris that it sounds like, John, you're going to cover some more information coming up. So for a sense of time, Chris, if you don't mind holding on to your question, and if we don't get that covered by the end of the presentation, please feel free to write back in and or we'll revisit it. But I want to ask, Wayne's question says, please elaborate on why build roads in the summer. I can imagine why not winter, but it seems summer could be too dusty, at least in certain areas, and thanks.
Can you repeat the question?
Yeah, so why do you recommend building those roads in the summer? Because in the summer could maybe be dusty, so why build in the summer versus the winter?
Oh, because of the amount of moisture there is in the subgrade. So if you have saturated soils during the winter time, you are not able to really compact that subgrade. So that, there's a certain ideal amount of moisture that different soils have in which they compact the best. So if that soil is already saturated, it will never compact well. So for example, if you have a clay soil, and if it's saturated and wet, if you just put clay on your hands, it's like a Play-Doh, right? So you will never be able to achieve the level of compaction that you need to be able to kind of seal that surface. Does that make sense?
All right, we'll take one more question, then we'll continue on with the presentation. And the next question is, does the need for less rock when using geocloth offset the cost of the rock when not using geocloth?
I would say, John, did you want to?
Oh, I was going to let you answer and then elaborate a little bit on it. So
I would say no. I think so. The geogrid and the geotextiles are about $10,000 to $15,000 per mile, and there's also an issue with the maintenance. You need to make sure that you know exactly where that geogrid or geotextile is placed, because if you have to reshape or blade the road, it might come off, and if that happens, then you have to kind of redo everything. Those are definitely more ideal for just kind of a spot treatment.
And that was what I was going to emphasize as well, is that geotextiles are really appropriate for certain places, but once you put them in, it does change, how you maintain that road, because as Fran said, if you're grading that road and the blade of the grader catches on that geotextile, you can rip the whole road out. with it. And so if you've got geotextile down, you really need to be very careful about maintaining adequate gravel on top of it, and then maybe even identifying where that begins and ends for it, so that in the future there's no question about where you need to have a different maintenance procedure.
Well, thanks, John and Fran. Great answers and questions, and I encourage people to keep asking those questions. Type in some more as we go through. We'll have time for some more Q&A at the end, and I'll hand it back over to John and Fran to continue their presentation.
Okay, thanks, Julie. And this is the answer, or maybe this is the answer that to the question that Chris McWhorter asked about sizing culverts. So what I'm going to go through here is a process to use that you can use, a web-based system for figuring out what the 50-year peak flow is at a specific culvert location. And the Forest Practice Act requires that culverts be able to pass a 50-year storm event. And I'll make the case that I think that's a really very much of a minimum size for it. So there's two ways to do this, or I guess there's two ways to do this. Traditionally, in the workshops that Fran and I have given, we passed out USGS quad sheets and had people actually draw the watershed around a specific site, and then we used dot grids to figure out how many acres was in that, and then we went to a figure in the ODF Forest Practices technical note that said what flow can be expected in this region of the state. Luckily, there are a couple of easier approaches to do this now that I think are more appropriate for most people. And both the U.S. Geological Service has a website, or has a program called StreamStats. The Oregon Water Resources Department has a similar process that you can use in the reference materials that Fran and I prepared. There are links to both of those sites for it. The USGS stream site, StreamStats site, is down here at the bottom of this figure. So you get into the site, and both sides basically put up a map. In the case of the USGS, it's a map of the US. In the case of the Oregon Water Resources Department, it's a map of Oregon. And you are, the process is that you zoom down to delineate where you want that stream estimation at. And so you keep going at finer and finer levels in these web maps until you start getting streams that show up as these kind of jagged edge streams along here. And then what both programs allow you to do is you can put a point in, and in one of those basically boxes that are in the streams, you click on that point, and then what happens, USGS is more interactive for it, so you can actually watch this stuff happen. And then what the program does is it delineates the watershed above that specific point, and you see that in yellow here in this figure with it. And then once that watershed is delineated, then you're going over to this side here, and you're telling it that, okay, you want the peak flows estimation out of that. And both programs are using essentially the same set of equations that takes the soil type, it takes the slopes in that area, it takes how much rainfall is likely to come there in terms of rainfall intensity, and also whether the ground is likely to be frozen or not in December. Because if you get rain on snow or rain on frozen ground, you get a lot more water because none of it is soaking in. So what happens is that with the USGS, you get a report right away with it. With the Water Resources Department, you put your email in and it sends you a report back. And then what we're really interested in as a result of that you're interested in this, is that on the left here, you get this table that basically is the peak flow estimates at that point for it. And then we want to use another piece of information that's coming out of the ODF Forest Practices Technical Note number 5, which is the capacity of different diameters of culverts. And they do this both for the circular culverts or round culverts on the left, or the pipe arch culverts, or what some people refer to as squash culverts, and that's actually how they are made. They do actually squash a round culvert to turn it into that pipe arch. And so if we look at this particular example that we had earlier, what we want is, so we have a basin there that's fairly small, less than 1/4 of a square mile in here. And we want to figure out what the culvert sizing is based on that table in the Forest Practices Technical Note. So I want to emphasize the 50-year and the 100-year peak flows. Recall that the 50-year peak flow is what's required under the Forest Practice Act, and then I'll make a comparison to the 100-year peak flow. Okay, so if we look at this from the 50-year peak flow, which is 15.6 cubic feet per second, so that's a 27-inch round pipe, or a 35 by 24-inch pipe arch. So this is pretty small pipe for it. But you would have a hard time at probably actually finding a 27-inch round pipe for it. If we think about the fact that we're getting changing climate conditions here, we're getting more intense winter storms for it, and they're more frequent as well. I would make the case, or I do make the case, and actually put it in practice when I was doing this, of upsizing culverts for it. And in this case, for the 100-year peak flow, that's a 30-inch culvert. That's a little bit easier to find. Probably 36-inch culverts are no more expensive than 30-inch culverts. So the case that I would make here is that you will sleep better at night during these intense winter storms if you're comfortable that your culverts are sized appropriately, or are possibly even oversized to handle that water, and that the increased cost for going up another 3 inches or another 6 inches or even another foot in the size of the culvert is not going to be that significant a proportion of the total cost of putting that culvert in, because you've got machinery in there, you're going to have some rock associated with it. And so the pipe is going to be actually a fairly minor part of the overall cost of the project, and the added cost of going up a size or two is going to be fairly minimal for the potential benefit and peace of mind that you will receive for it. So these pipes and this pipe sizing process here are really for non-fish bearing streams for it. Once you get into a fish bearing stream, the calculations are different for it, and the procedure is changing as literally as we speak, probably. So the first thing to know is that in a fish bearing stream, the diameter of the culvert must equal the active channel width for it. And you can get a pretty good idea of the active channel width by just looking at where the vegetation changes, or where it goes from no vegetation to vegetation along the stream bank. And if you have questions about this, you can always get in contact with your stewards at Forestry to come out and take a look at it and give you their idea of what it is for it. So that culvert must be the same width as the channel, or the diameter the same as the channel. It must be the same or a lower gradient as the stream in there for it. So you don't want to over steepen the culvert as the stream goes through the culvert. You don't want to over steepen that, and I'll talk a little bit about why that's the case. The gradient has to be less than 8%. Unless you're getting an engineered stamp design for it. And then most importantly, and this is what's evolving right now, because ODF is changing their guidance for this, But in currently, culverts have to be embedded in the stream for it. And they need to be embedded 40% if it's a round pipe, and 20% if it's a pipe arch for it. And the reason for that is you want this bed load, remember the term bed load, you want that bed load in the pipe, and you want that, that composition of it to be fairly similar to what's above and below the culvert in there. And so the reason that the culvert gradient must, match or be lower than the stream gradient is if you have a very steep culvert in there, that gravel is just going to get washed out in the culvert during flows, especially during high flows for it. And the other thing that still needs to be considered in all of this is even after that embedding process, the culvert still has to pass at least the 50-year flow in it. And so that means for a round culvert, you've lost about 30% of the capacity of it. So you've got to upsize for that. You lose less capacity in a pipe arch culvert, but it's still 20%. So, because of that embedding, you're probably going to be going up another size in the culvert for it. But like I said, be aware that those the guidance, the ODF guidance, and ODF is working with the Oregon Department of Fish and Wildlife on this, that's evolving. And so again, if you think you're going to be replacing culverts, and particularly if they're a bigger culvert with it, keep in close contact with your ODF stewardship forester for this, because they will be aware of kind of what's changes are likely to be on the horizon for it, and will help you, resolve any potential problems for it. The other thing to consider, and it's too complex for really to get into right now, is that once you get above maybe a 6 or an 8 or a 9 foot, certainly a 9 foot culvert, you might be better off looking at an alternative, like either a half pipe with concrete stem walls on top of it, or bridges. There's a lot of interesting designs out there for bridges now that resolve a lot of these problems with larger culverts for it. And at some point, and it's probably the 6 to 9 feet, the cost calculation changes so that a bridge can actually end up being cheaper than a culvert for it. Okay, so I think this gets back to Francisca talking about how to make sure that, how to make sure that your roads are going to perform well this winter.
Thank you, John. Yeah, so now we will talk a little bit about road maintenance and some sort of a routine maintenance for roads. So a good practice is to have forms or some way of keeping a record of roads every year, and kind of identifying some potential problems before the winter comes. And, we always talk about the best tool and the best friend that you have in terms of keeping your roads well is to have a shovel. The shovel is the absolute best tool to keep you out of trouble. So we call him Mr. Shovel, and he will always be your best friend if you want to keep your roads functioning. You should always, sometimes there are way too many things that need to be done, but prioritizing can be the best way of, at least going through the winter if there are way too many problems. And one of them is to prioritize drainage problems, right? We just already talked about how important it is to keep water off the roads, off the surface, and into ditches. Any potential for sediment discharge, potential fill or cut slope failures, landslides, arc-shaped cracks or infill of the roadways, and fish passage, right? Stream crossings. John just talked about that and how important it is to have that in working conditions when the winter storms are coming in. We do have a form that is included on the Forest Roads, the Woodland Roads Field Guide that we have in extension that has all the instructions on how to follow that and just kind of keep a good record of your roads. It just divides the roads by sections and kind of looks into different problems that you know, might identify in the road. The other one is ditches and culverts, and this is when the shovel comes handy. You know, keep all of those ditches and culverts clear of woody debris, leaves, mud, and gravel, because those will seriously impair the ability of the water to just flow wherever it needs to go, right? In many, you know, for the most part in culverts, try and clean above the culvert inlet, so you know, debris cannot just go straight into it. Inspect all of these before and during the wet season, especially after a big storm. Look for ditch erosion. This ditch erosion indicates that there might be a little too much water accumulating to get into there. So, you know, you might need to place an additional culvert further down the road, so there's not enough, there's not too much water accumulating. If you see some erosion on the culvert exit, there's ways of kind of dissipating that water energy by using a hot pipe or riprap or, you know, large woody debris that can just kind of help stop that and stop that erosion. The running surface, we talked about how important it is to keep the water off the surface. You know, check for potholes, ruts, washboarding, and erosion on the surface. You know, there's people talk about vegetation, and in some cases they think it's a good thing, but for the most part, it can impair the proper drainage of the road, and it could also become a wildfire hazard during the summertime. Reshaping might be the way that might be something that you need to do if you're observing that there are potholes or the water is going in the places that it shouldn't be going, and that includes blading and adding material or compacting and just basically repairing the surface so the water can keep flowing towards the ditches or the sides of the road. So right now, I will go over one of ODF's technical notes, and this is technical note number 8. They have several of them. We have references in which you can just go online and read them. They're very, very useful. In this note, it highlights the road drainage systems and talks about that special attention to drainage needs to be paid in the following situation, including near stream crossings or in wetlands, on roads that are parallel or very close to streams, on roads where the use is changing from not being used at all to active timber hauling, especially in the wintertime. When reconstruction old roads, especially side-cast constructed roads or in steep slopes that are steeper than 60%, and in existing roads where gullies have developed in the ditch or at culvert outlets. And if you wonder why we need to pay special attention to all these situations, is because when the winter comes in, bad things happen. I mean, we had this situation with one landowner who had a road right next to a stream, which is a legacy road, and this was a very expensive repair. So that's why we need to really keep a good eye on how things are looking right before, the really heavy rains come in. So this is the rule that it talks about drainage on the Oregon Forest Practices Act. And the purpose of this rule is to provide a drainage system on new and reconstructed roads that minimizes alteration of stream channels, and the risk of sediment delivery into the waters of the state. This rule has 5 different parts, and we will go over each one of them. The first one is that operation should not concentrate road drainage water into head walls, slide areas, high landslide hazard locations, or steep erodible fill slopes. So basically what this is asking is that roads, you should not collect drainage and discharge it into steep slopes or areas in which there's a high potential for landslides. These include head walls, slide areas, steep erodible fill slopes, and high landslide hazard locations. And the rule has, if you want to look into it, in the resources, they really have a very specific description of those high landslide hazard locations. Because what can happen is that, if there is a failure, then there could be a very large sediment input put into the streams. So that's just their first priority in this rule. The other one is that operation not divert water from stream channels into roadside ditches. So for stream crossing locations, culverts should always be placed. It is not okay to get a stream to go into a ditch and then back down into another stream. So because ditches will erode more easily than a regular stream, this is a very high potential for erosion and a lot of problems. So in very simple words, let the water run its course. You will not win against the water. Operators shall install dips, water bars, or cross drainage culverts above and away from stream crossings so that the road drainage water might be filtered before entering waters of the state. So the forest floor can absorb large amounts of water. So it can be used to filter if there is any sediment coming in the water from the road. So it can be filtered and then it doesn't go into the stream. The more distance there is in between cross drainages and the steeper the road is, the more likely that the muddy water will increase. So they do have an actual table in which you can look up how much distance you need for filtering this water if you have a stream crossing. So for example, if the road grade is between 6 to 12%, and the distance to the next cross drain uphill of the road is, for example, 300 to 600 feet, then the filtering should happen 60 feet above that, that stream. And that means that the outlet of that, that crossing needs to be 60 feet away from the stream. So that's the appropriate distance to filter for that. So of course, the steeper it is, the distance needs to be increased. Then we have the 5th part says that operators shall provide drainage when roads cross or expose springs, seeps, or wet areas. So it means that where there's water saturation, I was talking about the very beginning, the road will not be functional. If we have a subgrade that is weak and is saturated with water, we are going to have definitely problems with the road, and the road might not be functional. So something needs to be done to be able to filter that water, to get that water off. So if the flow is really high, then a perforated culvert can be used, or a French drain, or also geotextiles. As we were talking about geotextiles, if there's a spring or a very wet area that is permanently wet, we can use these geotextiles to keep that water off the surface and the road functional. And the last one is to that the operator shall provide drainage system using grade reversal, surface sloping, ditches, culverts, or water bars to minimize the development of gullies, erosion of the road prism, or slopes below the road. So the first one is the surface shape. As we talked about, crown roads, inslopes or outslopes, so we can keep that water off the surface. And then the next one is to keep cross drainage structures spaced in a way that they will keep an adequate drainage to the road system. And for the most part, culverts are the ones that are mostly used for cross drainages, at least in Western Oregon. And then next to that is water bars or ditch outs. So these need to be spaced depending on the road grade. So the higher the road grade, the steeper the road, the closer together those drainage needs to be. And this is the ODS separates this between normal soil and erodible soils. And by erodible soils, they mean, I think they have decomposed granites and volcanic ash within others. I would say clay, that would be one too. So that's the consideration that I would make for those type of roads. So when we have wet weather operations, there are some things that we need to really look for. First of all, durable surfacing or rock or any other effective measure on road segments that are connected to streams, and that needs to be a sufficient amount of rock that is providing, a dry surface on the road. As I was talking about earlier, and we were discussing on the questions, aggregate needs to be placed before the wet season and just in preparation to the rains. If ice or snow happens, for the most part, the rule, it's not a rule, but a rule of thumb that heavy traffic should be discontinued after thawing, because what happens is that the top layer of the road thaws, but the bottom, or like further down in the road deeper, there's still ice or is still frozen. So the water that melts on the top creates this mushy road, and that's what is called pumping that happens on these roads. So it's better to kind of wait out until thaw, it happens completely. As we were talking about earlier, in wet spots that are wet, wet year-round, the bigger size aggregate is best, or geotextiles to provide strength and separation. And as I was talking about at the very beginning, remember that the subgrade is the foundation, and the strength is conditioned by the wet weather, so that the wet weather will limit what you can do and what you cannot do on that road. When timber harvesting is happening and hauling in the wintertime, it's good for you to establish some sort of criteria for use and when hauling should stop. When things like the picture on the lower left happens, of course, that's a time where you should stop. And making sure that you have adequate compaction of the subgrade on the surface. that you have an adequate aggregate thickness for that kind of road in that situation, and of course, adequate drainage of that water. So here I have the final take-home messages. Roads are very complex, more complex than we often think about. They are expensive structures that need constant maintenance. If you keep good maintenance on your road, you should, not have problems for access. They have environmental implications, as John was talking about, especially for water quality and aquatic life. They're regulated, so you have liability on those as well. So these are regulated to reduce negative impacts to the environment. And the single most important thing to learn today, just keep water off the road surface and sediment delivery away from streams. So those are the two most important take-home messages. Good maintenance and proper construction will keep your costs low and keep you free of troubles. So thank you. And now I'll pass it on to you, Julie.
Thanks, Fran. Well, thank you to both you and John for a lot of really great, helpful information. I want to thank our audience for keeping with us. We're right up near the 4:30. What we're going to do is go ahead and keep answering questions until about 4:45. So if you have them, or we'll keep going here for at least a few more minutes on questions. There's a few there. Also, we'll post a poll to help get your feedback on how this webinar was and anything you'd like to share. And then a reminder that we're doing Tree School Online once a month, and our next one will be, this actually should be in December. I think they got ahead of us here. So this would actually be coming up on in December. Will be our 40 years of Christmas trees. And so we're doing them on the second Tuesday of each month. So it'll be on Tuesday, December 14th, will be Chal and Judy talking about Christmas tree experimenting and what's new and what stayed the same all those years. So a couple of questions that have come in for you and Fran and John. The first one is, how do you know if you have a fish-bearing stream? And so I think you mentioned that briefly, but could you go back and talk to them a little bit about that process with ODF?
Yes. So that's a good question. There's a couple ways to go about doing this, Heidi. The first is if you're planning to do an operation, on forest land, you'll need to have a notification, to file a notification with Oregon Department of Forestry using their web-based system that's called Ferns. And when you do a map in Ferns, and I guess you don't, don't guess, I've done this, you don't actually have to file a notification to get into it. But the map process in Ferns, one of the map layers is the ODF stream types on it. So there'll be a little button over on the right of the screen on the map. And if you click ODF on it as the layer to show, it will show you what the stream types are on there. Now that's a bit of a convoluted process. So probably the easier way is just to contact your ODF stewardship forester and ask them for it, for the stream designation for where you're concerned about for it. And then if you're, familiar with GIS and things like that, there's other, those layers are publicly available through ODF, but then you would have to have the capability to use some sort of GIS system to get that information.
Great, thanks, John. So Heidi asked, what is the best way to repair roads with burned out stumps on roadsides?
With burned
stumps on roadsides. So maybe to repair the roads after a fire, or maybe after stumps have burned.
Well, I guess the main difference that I see in there is that you should expect to have a lot more water than those roads used to have when the trees were there. So I guess it might be to, revisit how far the closed drains are and how much water is accumulating now that the vegetation is gone. But operationally, I don't see much of a difference between, whether the trees on the sides are burnt or not. I don't know if you, John, have any other.
Yeah, I don't think so. The only thing that if they're on steep slopes, then you might be a little more concerned and spend more time making sure that you're not getting some slumps of the banks into your ditches for it. That and like I said in the discussion about landslides, that's likely to happen, 5 to 7 years after the trees die or so. For it. So if it's a road that cuts across a steep slope, then you may have potential problems with slumpage and slumpage into your ditch. And then if the ditch gets filled with soil, then that water that's in the ditch is going to divert off either into the road surface, and particularly if you have tire tracks going down the road, the water will go into those tire tracks and erode it, and that can be a significant problem. So I think the concern here is not so much the stumps, but the fact that you might have increased bank slumping or sloughing off that's going to fill your ditches. And to go back to Francisca's key point is take a shovel with you. The shovel can be your friend depending on how much you've got slumping in, but make sure that those ditches are clear, which also means that during the winter season, you're probably going to want to go out there after every significant storm and drive your roads, and just to make sure that the ditches are clear for it. And that's a good practice, irrespective of whether you've had a fire or not, but it's just exacerbated with fires, I would think, where you don't have much vegetation holding the soil back.
Yeah, and I will also add to that a little bit the fact that, if it's already a landslide prone location now, if you don't have trees anymore and burnt, then that can also be an additional problem compared to when it was not burned.
Yeah, and I mean the best thing that you can do is just to make sure that the water is draining off of the road, so it doesn't get ponded up, it doesn't saturate the road fill, because that's when you start getting slides happening, or increases the likelihood that you're going to get a slide.
Great suggestions. Well, thanks again to everyone that's attended today. And as a reminder, this will be recorded and posted in a few weeks to be available. We have resources that are available if you want to go back and take a look at. We're going to keep answering questions until about 4:45 until we don't have any more. We only have one more right now. So just a reminder, if you want to add any questions in there, please feel free to do that at this time. So this one is a little bit going back to rules, and in a revised statute, it states the best management practices to maintain water quality, that the State Board of Forestry shall establish best management practices and other rules applying to the forest practices for ensuring waters of the state are not impaired. And so the question is, what is the BMP, or where is it located? Is it in the Oregon Forest Practices Act itself, or is it maybe one of the forest road management guidebooks? Or is there a checklist? So I think if one of you wanted to take that, or both of you, and it sounds like there are several things commented there on maybe resources and or where those rules are.
Okay, so I'll start that because I'm just teaching a class on that, about an hour and a half, in fact, with that. So Chris, the BMPs are found both in the forest practice rules, as separate from the act with that, and those are available either as a newsprint booklet from your local ODF office, or you can find them on the web. The BMPs, so those have a set of standards in there for it. But the forest practices technical notes that Francisca and I have both been referencing are really lay out the BMPs in there for it. And that's the things like cross drain spacing and culvert sizing and wet weather hauling and high landslide hazard locations. All of those are covered in the forest practices technical notes for it. And then I would be remiss if I did not talk about OFRI's Oregon Forest Practices Illustrated Guide, which I'm sure Julie has a copyright at hand that she can hold up and show you. But
Actually, Fran is even on it more than I am today. Look at that.
So that in my estimation, and I use that as a textbook for my class of forest engineers. That is the first place that I would go for everyone attending. The first place that I would go to look for, how to conduct operations consistent with best management practices. And so those guides are available from OFRI. If you contact them, they will mail you one, or they're also on the website as well.
Thanks. Fran, did you want to add any other notes to that or other resources you want to mention?
No, I just wanted to confirm what John was saying and highlight again how useful this guide is in being able to digest all those rules a lot better and more practical for anyone to put in place in their property. It's a lot easier to understand.
And I would reiterate again that your best source of information or a readily available source of information is to contact your ODF stewardship forester for this. So they have a great depth of knowledge on the rules. They've, if they've been around for a while, they've seen everything for it. And so they are really, their role really is to assist you in complying with the Forest Practices Act with it. So they're much more of in a technical assistance role than as a rule enforcer, although they will do that. But it's always good to contact them before you have a problem rather than see
right, especially if you have any specific question.
And then do you also have a recommendation on maybe where to find contractors that have experience with this, such as maybe working with the local OSWA chapters to find people, or the Oregon Professional Loggers group, or anything you might recommend for if people are looking to hire contractors that have experience with this?
So, well, one of them is the Oregon Professional Loggers. So they are the ones that are certified. They need to have knowledge of the Forest Practices Act and the rules to be able to get their credits and their continuing education. So that would be one. And the other one is the Oregon Forest Industry Directory, in which you can search different service providers depending on where you are. It has a map and in different locations, and several different kinds of filters that you can look for different providers, which is very useful. We used to have a log buyer list and provider list that I would show on my classes, but they changed so much that we decided to partner up with Scott Levengood and the Oregon Forest Industry Directory online, in which he has somebody who is constantly checking and making sure that the information is the most up-to-date as we can possibly have it.
Great, I think that's helpful. And then a question from Scott, or maybe a suggestion, is about suggesting that roads are wide enough that drivers can use the whole road. Driving in the center or same place may cause rutting, where driving in different locations helps keep the ground. Any further things about that, about width of the road, or about that driving locations?
Nope. I mean, I've heard a number of landowners who have taught their kids to do exactly that. Don't drive in the same place all the time. So
Yeah, that's a great suggestion.
Also helps keep the vegetation down, and you don't want vegetation growing on your road. So.
Great. Well, we appreciate everyone that sent in a question and their time today and have stayed for the overtime. Well, it doesn't look like we have any other questions that have come in. So thanks again, both Fran and John, for all your great information today. Really helpful, especially as we're heading into those winter months and needing care of our roads. And thanks to Glenn for co-hosting with me today. And we hope we see people on the second Tuesday of each month for the next Tree School Online. And I appreciate again, everyone, those questions and your caring about this topic, and good luck with all your road maintenance and care and building in the future. So John and Fran, any last comments you'd like to add before we close out?
Yeah, I would just wanted to thank you and Glenn and everybody for inviting us to give this webinar. We have offered some of roads workshops, which are day-long workshops around the state. We have had very good comments about that because, roads are really important, and unfortunately we don't really care so much about them until they break down and we can't go over them, or bad stuff happens. So it is really important to have preventive measures, especially if timber hauling is going to happen. So thank to you and Glenn for inviting us to do this, and also thanks for everybody who participated and joined us today.
Now, and I would add, I certainly appreciate Julie and Glenn and my partner Francisca here. One thing that I've learned over the years that is if you really want to understand how your road is going to function in the rain, you need to go out there in the rain and watch it function. And that's where I've learned most of what I've learned about roads is just being out there. And walking the road during rainstorms and seeing what's happening with it. And so good observation, is important. And when you're out there watching how your road is functioning in the rain, bring your shovel, because you've quite likely you may have an opportunity to fix something. And if you can fix it with a shovel, it's a whole lot easier than if you have to get a excavator out or a backhoe out for it. So.
Well, great suggestions. Thanks again. And thanks everyone for joining us today. And we'll look forward to seeing you at the next Tree School Online webinar.